Hey everyone, this is Ms.Parmar here. Today we're going to be talking about codominance. This is when you see a cooperation of two traits. So you're going to see two traits appearing at the same time. Let's go ahead and jump into this. This is a problem that I'll be doing, and then we're going to do one together. A black feathered chicken breeds with a white feathered chicken. Their offspring will be both black and white. So you see them both cooperating. They won't be gray, rather there will be spots of both colors. In this problem, a black chicken is crossed with a black and white chicken. Okay, so I'm going to go ahead and create a key for myself. And the three genotypes that we're seeing, or phenotypes, is black, white, and then chickens that are both black and white at the same time. That's codominance. They're both showing up. Alright, so notice here that I'll be writing these differently because we're doing codominant. Dominant means big letters. So I can only use big letters in this situation. So for black, and pay really close attention to this, I'm using big C, big B, big C, big B. So notice how the trait itself is for color, I'm using the letter C, but since this is codominance, I'm also going to add this superscript of a B. And that's a big B. Alright, for white, it's going to be big C with the superscript W, big C with the superscript W. I'm choosing these letters. So you could have chosen an H, you could have chosen an A, but I thought it made sense because black goes with B, white goes with W. But if I'm going to show both at the same time, this genotype is going to be C with the superscript of a B, and then C with the superscript of a W. You see how it has both black and white. So this is a black and white feathered chicken. This is my key. But in this problem, a black chicken, that's one parent. I'm going to do CB, black chicken, is crossed with a black and white chicken. So that is CB, CW. So I'm using my key to help me. Alright, now I got to cross them in the Punnett square. So let's go ahead and bring this over. C, B, C, B, that came from here. And the other parent was C, B, C, W. Okay, so remember these come down, these go across. So I'll show you how this gets filled in. CB, CB, so from here and here. CB, CB, from here and here. CB, CW, coming from here, and CB, CW, coming from here. Alright, so now we're going to analyze these children, these four chickens. We first need to figure out the genotype ratio. So I'm looking at here, and I'm only seeing two different kinds of genotypes. I see two of the offspring are C, B, C, B. Two of the offspring are C, B, C, W, and none of them are C, W, C, W. Now, again, we're working with codominance here, so let's talk about what their phenotypes are going to look like. So going back to this first one, two of these kids, this one and this one, are both going to be black feathered chickens. And two of them are going to be black and white at the same time. I'm just putting BW because it's much easier than to write black and white. And then, of course, 0 of the chickens are going to be white. So this is that phenotype ratio. I could have written this as a fraction. If I did, this would have been 2 over 4, 2 over 4, and 0 over 4, which is also equal to 1/2, 1/2, and of course 0. So that's just another way you could have done that. Let's answer the one question. How many of the offspring, their kids, will be black and white at the same time? Okay, remember, we've done this. Look over here. There are 2 that are going to be black and white at the same time. This one and this kid. And I know this because they have both the B, which stands for black, and W, which stands for white. This is how we would do a codominance problem.